Welcome to this session on finding the workspace of 4 Revolute jointed robot. This is the same robot which we had considered earlier. What do we mean by workspace? By workspace we mean uh, no, before that, let us recall that on each of the links we had assigned the local frames of references as per DH parameter, and on the last link, the origin of the frame of reference would lie somewhere here. Let us call it as O4. By workspace, we mean the set of all points that O4 can reach to. What do we mean by that? And suppose I change one of the joint angles, then the location of O4 changes. So the previous location, the current location, and some other location, if I collect all of them, then we get the workspace. To understand the workspace, we should have some strategy. What we will do is we will keep theta 1, theta 2 as constants and just vary theta 3 and understand the set of points that O4 passes over. So now I'm not touching theta 1 and theta 2. I'll just change theta 3. Let us see how O4 changes. Okay, so these are the set of points that O4 can reach to. It is not very hard to see that if I collect all those points, it would be a circle. So that's what it is. And indeed, the set of points would appear like this, which is a circle centered about this axis. Now this is the curve. I will call this as theta 1, theta 2 constant arc. Now the position and orientation of this arc would depend on theta 1 and theta 2. For example, if I change theta 2, the curve's position and orientation also would change. So in the second stage, what we will do is we will change the value of theta 2, see the set of locations for this curve and collect all those locations and form the next stage, which we will call as theta 1 constant surface. You know that when a curve sweeps over some value, it typically gives a surface. So let us see, as I change theta 2, what surface is swept by the circle. The surface it actually sweeps is what is shown here as a orange colored hood. It turns out that this hood is actually a semi-spherical surface, but proving that is not of importance right now. And of course, we are going to call it as theta 1 constant surface. And another thing to note that on this surface, no matter what value we give to theta 3 and theta 2, this O4, which is currently located here, would lie on this surface itself. Let us just test it. See, here I am changing theta 3. It does lie on the surface. Now I change theta 2. It still lies on the surface. Now let us move on to the next stage. In the next stage, we have this theta 1 constant surface. The position and orientation of this surface is dependent on theta 1. If I change theta 1, its position would change and perhaps even well, its position would change, perhaps even its orientation. Now what we want to do is we would want to collect all these surfaces. For example, this surface, this surface, this surface. So different surfaces for different values of theta 1, and combine them. So when we combine those surfaces, we will actually get a volume, and that becomes the workspace of the robot. Now let us see how the sweep would appear as. So if I sweep this surface like this, what I'm going to get is actually this. So this is the volume that is obtained by sweeping uh, this surface about theta 1. The entire robot could be seen under the hood. So this is actually the hood. So as theta 1 about this axis rotate, this entire hood would get rotated about this axis, and we get uh, the volume like this. So here, even though the, some of the graphics may not be very correct, so all this, see here you interiorly will see a circle, and in an exterior also you will see a circle. So between these two, all the space is actually filled. So there is a hollow portion here, and this is an exterior surface, and in between everything is filled. Of course, there is no material beyond this particular line. But otherwise, between this surface and between this surface, the entire material is, the entire space is filled. It means point zero 0.04 can reach to any point in that space. So this is the workspace of the robot, which we were looking to find out, and